Okay, good morning. Week 12. Okay, so one more week to go. So today we're going to do 2D and 3D Mohr Circle, and then we're going to have how we implement shear stress yield criteria, okay, which is also known as Tresca, into Mohr Circle. And week 13, which is our last week, is the topic will be on combined loading. Okay, combined loading. So combined loading, we're going to have normal stress, shear stress, Mohr circle all together. Okay, that's what we call by combined loading. And actually design a part or select material under a specific loading condition so that it can withstand the stress. Okay, so that is so-called the finale. Okay, and this is what it's all about, assembling everything together. Right, so we're going to look at Mohr circle first. Okay, we're going to look, I'm going to change my, we're going to look at Mohr circle. So what is Mohr circle? Mohr circle is to analyze normal stress and shear stress acting on a specific position and to determine the principal stress. That's the purpose of Mohr circle. And later I'll say why, or next week I'll tell you why the principal stress is so critical. Okay, so let's learn Mohr circle first. So normal stress. Okay, normal stress are stresses acting perpendicular to the surface. Okay. So if I were to write down the formula, you say, yeah, we've seen this before. So how to calculate the normal stress? Okay, so to calculate the normal stress is equal to sigma is equal to P over A plus by M Y over I. You guys will say, yeah, we know this, right? So which part of Mohr circle is this? Okay, when we say normal stress is equal to P over A M Y over I. So if we have a structure that is simply supported, right? They're simply supported. And we happen to have a load exactly at the center. Okay, so exactly at the center. Okay, so this is P, and we will draw a transformation. This is X, Y, rotation about Z, right? So we will have our normal stress. Sorry, we will have our shear force diagram, right? So this is our shear force diagram. Okay, so this is X, this is V, right? Then we will come over here, and this distance will be, this height or this magnitude will be P over 2, and over here will be minus P over 2. Now you all will know why after doing last week's homework. Right, they will come down, do this, and then it goes back to 0. So we know we have a shear stress over here, right? The shear force will contribute to the shear stress, and we know what formula this will be applied. So the shear is equal to VQ over IT, right? And then we have normal stress, right? We have our normal stress. So the normal stress will contribute by the bending moment. Okay, so we have our bending moment. Right, so this is M, right? So over here, it will reach its max and then come down. So this is our bending moment diagram. Right? And this magnitude, if this entire length is equal to L, okay, from here to here, which is equal to L, right? This is equal to P L over 2, right? And for this, the moment will contribute to the what? To the normal stress. So this we have our, so this is our moment. So we have our my over I. So this is for centric loading. And stress can be also be P over A plus by my over I, and this is for eccentric loading. Okay, and this is for eccentric loading. So when we select material, right? When I was undergrad, I would say this is more important than the normal stress is more. No, okay. Both normal stress and shear stress are important depending on the loading situation, right? Okay. So now, how do we combine both of them together? Okay, so we combine both of them together by, so we combine the calculated normal stress, normal, and shear stress with Mohr circle to determine, like what I mentioned earlier, the principal stress. Okay, and then next week I'll tell you guys why principal stresses. Okay, now let's learn the two first. Okay, anyone, any questions so far, please? Anyone? Okay, no. Okay, so let's look at normal stress first. Okay, let's look at normal stress. So I want to introduce you to two terms. Okay, and let's draw our transformation first before I introduce you to the terms. So I'm going to introduce you. So now what we are drawing is an element. Okay, now what we are constructing is an element. Okay, so this is our element. So from here, right? So this is our element. Okay. So normal stress are stresses acting perpendicular to our surface. So for this case, this is stress X, right? So it's perpendicular. And so for this case, this is known as stress Y, right? So I'm going to put a situation, a scenario now, right, where stress X and stress Y both are positive, right? And I'm going to put in another condition whether now I'm not going to do any shear stress first. Okay, let's introduce normal stress first, right? And then our shear stress is equal to 0, right? And over here, sorry, I should write this down. Stress X is greater than stress Y. Okay. So now we are going to construct Mohr circle. Okay. So I'm going to construct Mohr circle now. So this is Mohr circle. Now, when I teach Mohr circle, we are not going to use the transformation equation. Okay. We are just going to draw the circle. Right? Because you can solve very complex problem by just constructing the Mohr circle, then use the transformation equation. Because the transformation equation is a black box. You don't know where you are. Okay. So this is normal stress, and then this is shear stress. And later I will highlight what I mean by that when we are doing examples. Okay, you will realize that constructing Mohr circle is much easier. Now, so on the x-axis is normal stress, on the y-axis is shearing stress. Okay, now the shearing stress, okay, you have to draw this. Okay, later on I'll explain. So over here, above the or positive shear or positive magnitude, ignore my last mention about positive magnitude will have a clockwise rotation of the element. Okay, the lower one will be anti-clockwise. Later on, I will go more detailed by what we mean by that. Okay, right. So from here, we can see 2 points. Okay, we can see. So this is our stress X. All right, this is our stress X. And over here, this is our stress Y. Okay, and then it's good practice. Okay, I want you to do this. Okay, it's good practice that this surface over here, you label it as point X. This surface over here, you label it as point Y. Okay, it's a very good practice. So we know that point X, right, have zero shearing stress, so it will lie down here, right? So down here, point X has a stress X has a value, shearing stress is equal to 0, so this is your point X, right? Over here, the other one, this is your point Y, right? So from here on, you can construct a Mohr circle. You can draw a circle now. You find where the center point is, then you construct a circle. Okay. And I'm going to introduce you to a term now, which is known as average stress. So where's the average stress? Okay, so I'm going to draw the average stress is the center of the circle. Okay, hold on. So this is the center of the circle, right? So this point over here is usually our point O, right? And then from here to here, this is our stress average. Okay. So I would like what we observe from here is both stress X and stress Y have magnitude and direction. So it's a vector. And the center of the circle is known as our stress average. Okay, so just remember the center of the circle is your stress average. So from here, we know that stress average is equal to stress X plus by stress Y divided by 2. Okay. Anyone, any questions? Is this clear? Okay. So as I said, I want you all to solve the problems with the transformation without using the transformation equation, but I would rather you construct Mohr circle. Seriously, okay? It's so much easier, and later on we go to complex problem. It's also very much easier, okay? Right. So this is one case, okay? And what we all observe is normal stress. So the normal stress is perpendicular to the surface. Let me draw for your another situation, okay? Let me draw another situation. If I'm going too fast or you guys are copying, let me know, okay? I'll give you time to copy. Are we okay? Okay. I'm so happy today, you know. I enjoy seeing how term test 2 grades are, you know. I'm so happy. Unspeakable joy, you know. You guys really do. I'm so proud of you guys. Stress X is the intention. So pointing away is in tension, okay? Coming down is in compression. Okay. So you will see when the arrow comes down, it is known as compression. When it's going away, it is tensile. Right? Or tension. So in this case, again, we will have over here a slightly different situation where you have stress X is positive, stress Y is negative. Okay. Again, the shear is equal to 0. Okay. So what does positive and negative means, right? So down here, the case before, everything is